Okay, welcome back to the last part of this lesson. So again, I asked you to take a look at this one where you have a population tripling every 3 years. How much must be in the current population for the population to grow to 2,657,205 in 36 years? So again, in terms of what we know here, we know if it's tripling, our base should be 3. We don't know what's in the current population, so our C is unknown. We need it to grow to that 2,657,205. Now, as for the x, now again, we can't just put 36 in for our x because it's not tripling 36 times in 36 years. It's tripling every 3 years. So how many times is it actually going to triple in those 36 years? Well, it's going to be 36 over 3, which is actually going to be 12 times. So it's going to be tripling 12 times in those 36 years. So our exponent is going to be 12. So in terms of our equation, hopefully we have everything we need now. So we know it has to end with that 2.657 million approximately. So let's put that in. We don't know what our starting population is. Our base is 3 because we're tripling, but it triples 12 times in those 36 years, so it's going to be 3 to the 12. So when all is said and done, we have to solve for C by dividing both sides of the equation by 3 to the 12. Then we can run everything through our calculator and get a final answer. So that should all simplify down to give me an answer of 5. Okay, so with that in mind, let's try a couple others before we call it a day. So this is going to lead a little bit into chemistry. I'm not sure if any of you have taken chemistry, you may have run into the concept of half-life. If you haven't, though, the idea behind half-life is it's the amount of time every kind of radioactive substance naturally decays over time. You leave it alone, it's going to start decaying, and each radioactive substance decays at its own rate. There's going to be some that decay naturally very, very quickly, and some that will take a very, very long time to decay. What half-life is, it's the time it takes to decay to half its original value. So, time, can't write today. The time to decay to half its original mass or value. Okay, so what that means, so you have this radioactive substance that has a half-life of 45 days. So it means that if you're starting off with 1,000 milligrams, in 45 days it will be down to 500. So in 45 days, you'll be down to 500 milligrams. Okay, after another 45 days passed, you'll be down to half of that, which is 250 milligrams, and so on and so forth. So every 45 days is going to go to half of what it was previously. So we're told you're starting off with 1,000 milligrams, so it means we're starting off with 1,000. We want to know how much will remain after 74 days. So in this particular case, we don't know how much is going to remain. Since it's halving, we're going to have our base be 0.5. And as for our exponent, again, in 74 days, it's not going to half itself 74 times because it only halves itself every 45 days. So our exponent is going to be 74 days divided by 45. Okay, so we can now start creating our equation. Remember, y equals c times a to the x. So y is unknown. We're going to start off with 1,000 milligrams. Our base is going to be 0.5, and our exponent is going to be 74 over 45. So we can run all that through our calculator and hopefully wind up with an answer that makes sense. Okay, so run this through. Let's see what we get. Okay, you showed up with about 319.87 or 319.9 milligrams. Okay, so again, the key here is since it's halving its original value, our base is going to be 1/2. Be careful with the exponent though, because in 74 days you have to take into account that's not halving 74 times, it's halving once every 45 days. So the exponent is 74 over 45. Okay, so last one I'd like you to try says the half-life of a certain substance called PD100 is 4 days. We're told that after 16 days the sample weighs 0.75. How much was the sample initially? Okay, so I want you to try and set this up completely on your own. Try and solve it, and when you're ready to go through it together, you can push play. Alright, let's take this one up. So again, we're told the half-life is 4 days. We're told that after a certain amount of time, 16 days, it weighs 0.75 grams. So that's going to be our final amount, or Y. We're looking for the initial mass, so that's our C, that's our unknown. So since we're dealing with half-life and it's halving over a certain period of time, we're going to have our base be 0.5. We have to be careful again with our exponent. So in 16 days, it's halving every 4 days. So how many times does 4 go into 16? It goes in 4 times. So if you think about it, we have 16 days, but in those 16 days, it's halving itself every 4 days. So you have 16 divided by 4, which winds up simplifying down to 4. Okay, so once we have all that, it's just a matter of running through using algebra to solve for C. So we have 0.75 equals C times 0.5 to the exponent 4. We divide both sides by 0.5 to the exponent 4. Okay, we're at a point where we can just solve for C by running it through our calculator, and it winds up giving us a value of 12 grams. So we start with 12 grams. After 16 days, it's going to be worth 0.75 grams. Okay, so that's it, that's all. So hopefully you've already done this first part over here. I assigned that after part 1 of the lesson, so hopefully that's done. So what's left now is a couple of other questions in the textbook that, again, hopefully aren't causing you too much trouble, and then you can work through the worksheet as well. So the worksheet gives you a nice mix of everything that's in there, and again, if you do everything that's on there, there's very little I can trick you with come test time. So hopefully that goes well, and that's it for the exponential functions unit. We're actually almost done the course. All that's left is a little bit to do on finance and using some of the stuff there. But other than that, that's it for the course. Okay, and that's it for now.